All right, welcome. Today we're going to talk about radicals. Our goal today is to simplify radicals without using the root function on a calculator. It's not as scary as it sounds. Make sure you turn on the closed captions in YouTube so you can follow along with what I'm saying as well. Let's get started. First, some quick vocab. First word here is the index. It is the number located in this spot. It tells us what root we're looking for. The radical is this symbol, okay? It tells us that we are looking for a root. The radicand is the number underneath the radical symbol. And we remember previously our exponent tells us how many times we are multiplying the base. In this case, it's the radicand. So those are the general terms. Let's use them, see them in action in practice here in a minute. So here, we do not have a number for the index. When there's nothing there, it's implied that it's the number 2, which means we're looking for the square root of 16. We're looking for the second root of 16. What does that mean? We want a number, a, such that when I multiply it times itself twice, I get the number 16. In order for this to be true, it means a squared equals 16, so a must equal 4. Okay, 4 times 4 is 16. This is what we call a perfect square. 16 is a perfect square, meaning it has a square root that is a whole number. And there are 10 within the first 100 numbers. We have 1, 4, 9, 16, 25, 36, 49, 64, I almost forgot for a second, 81, and 100. So when I take the square root of all of these numbers, I'm looking for the second root. Because I'm not writing anything in the index, it means it's a 2. Like we're going to use just the positive values. I have 2, square root of 9 is 3, square root of 16 is 4, square root of 25 is 5, square root of 36 is 6, square root of 49 is 7, square root of 64 is 8, square root of 81 is 9, and the square root of 100 is 10. It's helpful to sometimes memorize these. It makes simplifying radicals much faster. Prime factorization. What is that? Well, we're just going to factor a number and we're trying to break it down to its prime numbers. Factoring a number means finding numbers that multiply together that equal that number. Let's look at the number 36. 36 is even, so 2 is a factor, and it's the smallest prime number. 2 times 18 is 36. I can break 18 apart again. 2 is a factor because 18 is even, and 2 is the smallest prime number in there. 2 times 9 is 18. 9 is not even, but I know 3 is a factor of 9. 3 times 3 is 9. And now I have only prime numbers. And if you look, this kind of looks like a hockey stick. Sometimes I'll call this the hockey stick method. Okay. And so this just breaks a number down into its prime factors, all the prime numbers that multiply together that equal that number, in this case 36. So here's our first sample problem. We're going to simplify the number 24. Let's break it down using prime factorization, the hockey stick method. 24 is even. So underneath the radical, all this is under the radical, I have 2 times 12. 12 is even, so that gives me 2 times 6. 6 is even, so that gives me 2 times 3. And here's my hockey stick. I have prime numbers, I'm done factoring. What does this mean? This means that under the radical, I have 2 times 2 times 2 times 3. Well, if you look, I have a pair of 2's here. And that means 2 times 2, that's 4 times 2 times 3. 4 is a perfect square, which means I can take the square root of 4 and it comes out to the front and it becomes a 2. And I have 2 times the square root of 2 times 3 that's left over. So I have 2 times the square root of 6. Final answer. So let's do 96. It's a big number, so let's get started. It's even, so 2 times 48 is a factor of 96. 48's even, so that's 2 times 24. So I know what I mean when I say even is I know 2 is a factor of that number. So I still keep getting all these even numbers. And I'm done. I have only prime numbers here. It's a long-handled hockey stick there. And let's count the pairs of Prime numbers, I have a pair of 2's there. Let's use a different color. And another pair of 2's there. And I'm all out of pairs of 2's. So this gives me 4, which is that one, times 4, which is here, times 2, times 3. Well, if you look, I have a pair of 4's. That's 16. Square root of 16 is 4, right? Everything is under the square root. So if I have a pair of numbers, I can just cancel out the pair and write one of those numbers out front. So let's make it a little cleaner. That gives me 4 times the square root of 2 times 3, which equals 4 times the square root of 6. If I was to bring this back inside, I would see that I would get 16, right? I have to square this number to put it back under the radical. 16 times 6 is indeed 96, so we're good. What if I don't want to use prime factorization? Well, I can try to factor this and find a perfect square, either 4, 9, 16, 25, 36, etc. That is a factor of this number, the radicand. So in this case, I know 4 is a factor of 120. 4 times 30 is 120. And then I can just continue to factor 30 out to make sure I don't have any other squares in here, and I don't. I can only factor this out from underneath the radical. So I'm going to rewrite, whoopsie daisy, what happened there? I'm going to rewrite the radical with using the factors. So I have a perfect square, 4 times 2 times 3 times 5. The square root of 4 is 2, so it cancels out, and I write the 2 up front. So I have 2 times the square root of 2 times 3 times 5 is 30. And we're done. Recap. So to simplify, we can find the prime factorization or use our hockey stick method. Okay. Or we can factor out a perfect square to make it a little faster. When we do, we're still multiplying on the inside. You notice that for 120, I was able to factor it into 4 times 2 times 3 times 5. That's still technically all under the radical. This is the same as the square root of 4 times the square root of 2 times the square root of 3 times the square root of 5, which is why I have a perfect square here. I can just write this as 2, which is the square root of 4, times, and this all is underneath the square root, so I can put it all together under the same square root. 2 times 3 times 5, which is 2 times the square root of 30. Your assignment is to do the worksheet, simplifying radicals. If you're one of my students. If you're not, don't worry about this part. You know how to get a hold of me if you have any questions. Go ahead and reach out. Good luck.